subscribe and click the bell icon to turn on notifications.
In this section of the course, we're going to start taking a look at some of the most useful intermediate level functions and formulas in Excel. And the idea behind this section is really to give you a taster of the types of things that you can do with more advanced formulas to move your knowledge on a little bit from those basic formulas that we looked at earlier in the course, and really set you up for success if you plan to do the Excel Intermediate course. And we're going to start out this section by taking a look at one of the most popular functions, and that is the VLOOKUP function. Now, VLOOKUP is classified as a lookup and reference formula in Excel. And if we jump across to the Formulas ribbon, you're going to find it underneath the Lookup and Reference section, all the way down at the bottom. There it is, VLOOKUP. Now, if we take a look at this screen tip, because this is going to tell us exactly what VLOOKUP does. So it's going to look for a value in the leftmost column of a table, and then it returns a value in the same row from a column you specify. So what exactly does that mean in terms of data? Well, let's take a look at the example that we're going to use. Now, in this worksheet, I have a reasonably large data set, and this is related to movies. So in column A, we have the title of the movie. In column B, we have the year that it was released. In column C, we have the certificate it's been assigned. In column D, the date that it was released. In column E, we have the runtime or the duration of the movie. In column F, we have the genre that that movie belongs to. And then finally in column G, we have the user rating. And what we want to be able to do here is we want to be able to type in the name of a film and have it return the year, the certificate, the genre, and the rating from the table. And it's this kind of situation where we would use the VLOOKUP function. Now, the thing that a VLOOKUP relies on is a lookup value. So whatever it is that you're using to look up this information, in this case, the film name that we have in J2, that must exist in the table. So let's pull back the year using the VLOOKUP function. Now I'm going to type equals into the cell, and then we're going to start to type VLOOKUP. Notice it's come up in IntelliSense, so I can just press the tab key. Now let's take a look at the different arguments. Remember, the arguments are what we need to complete in order for this formula to work. Now, the first thing that this formula requires is the lookup value. So this is the piece of information that you're using to look up other pieces of information in the table. So for us, the lookup value is going to be the film. So whatever we have in cell J2. Now remember, this can change. I can type in all different kinds of movie names in here, but regardless of what I type in, because we're using a cell reference, it's always going to look up based on the value in cell J2. Comma, to move on to the next argument. We then need to provide the table array. So effectively, this argument is asking us, where is our data? What are we looking up this information in? Well, for us, our table array is this data over here. So I'm going to select the entire table. Now let's jump up to the formula bar to carry on editing. Comma. Now it's asking us for the column index number. And this is a really important part of VLOOKUP. The column index number is where you specify the column of information you want to return. So what are we looking up here? What is the result that we're expecting? Well, we're trying to return the year of the film Moonlight. So we want to return the year. Now, VLOOKUP numbers columns from left to right. So the title column is column 1, the year column, column 2, certificate column, column 3, so on and so forth. So our third argument here is going to be 2, because the year is column 2 in our table array, comma. Now, our final argument here is an optional argument. How do I know it's an optional argument? Well, if I take a look at the argument, you can see that it has square brackets around it. Now, any argument that you see in square brackets means that it's optional, so you don't have to input anything for this. But if I do press comma, you can see the arguments that we have, true or false. So what am I doing here? Am I doing an exact match or an approximate match? And this is related to the lookup value, the film that we're using to look up the data. Well, I want to exactly match the name Moonlight in the table. So this argument is going to be false. And I would say that the false argument on the end of a VLOOKUP is the most common argument. Now, if you don't put anything on the end here, remember this is optional, it's going to do the default, which is to do a false. So I'm just going to type false on the end and close off my bracket. That is my VLOOKUP formula. Let's hit enter and see if this works. There we go. So it's pulled back the year 2016. So if we look for Moonlight in the table, and it's this one just here, you can see that yes, the year that movie was released was 2016. So we've used the film name as the lookup value in this table, and we've returned column 2, which is the year. Let's do this again. Equals VLOOKUP, tab key. Lookup value again is what we have in J2. The table array is the same thing, so I'm going to Control Shift down to select everything. Let's click back up in the formula bar, comma. The next thing we need here is the column index number. So what piece of information do we want to return this time? We want to return the certificate. So counting from left to right, the certificate column is column number 3. And we want to do an exact match of the movie name in the table. So our final argument here is going to be false. But also remember, in Excel, you can type a 0 to represent false and a 1 to represent true. So I could put a 0 on the end here or leave it blank. Close the bracket, hit enter. Certificate is R. Let's double check that. Yes, it is. Now, one way I could make this a little bit easier on myself so that I'm not having to go in and select this cell range each time for the table array is to turn this data into a table or a named range. So I'm going to create a table. Control T. Click on OK. Now my data is in a table, and on the table design ribbon, I'm going to give my table a name. So let's just call this Movies and hit enter. Now that I have this table array named, I can use it in my VLOOKUP calculation. So this time we're going to pull back the genre. And I can see that the genre is column number 1, 2, 3, 4, 5, column number 6. So equals VLOOKUP. The lookup value is the movie. The table array, this time I can use the table name. So if I start to type it in, notice it comes up underneath in IntelliSense, tab to select, comma. The column index number, I'm looking for the genre, which we've established is column number 6. And I want to do an exact match, so I'm just going to accept the default here. I'm not even going to add that final argument. Hit enter. And yes, that movie is in the genre of drama. And just to show you another way that you can do this, you could also utilize the functions dialog box. So if we go up to the formulas tab and click on insert function, I'm going to search for VLOOKUP. Let's click on go, double click to select, and now I can complete my arguments in this way. So the lookup value is J2, the table array is movies, the column index number, well this time we want to return the rating, which is column number 7, and we want to do an exact match, so we need a false argument on the end there. Let's click on OK, and there we go, 7.5. So now what this means is that every time I change the film or type a new film into here, all of these results are going to update. So if I type in Jackie and hit enter, you can see that those results have changed to reflect this movie in the table. What about if I type in, let's go for La La Land, hit enter. Again, at the top, those results have now changed. So that is how you do a basic VLOOKUP using exact matching.
Hello everyone, welcome to a new tutorial from Simon Says It. In this video, I'll show you how to use the match function in Excel. Excel consists of a variety of functions that help in performing a variety of operations at ease. If you want to find the position of a particular value when using Excel tables or pivot tables, you can use the match function. The main purpose of the match function is that this function is used to search any data in an array of cells and returns the relative position of that particular data. The syntax of the match function takes 3 arguments: the lookup value, the lookup array, and the match type. The lookup value is a mandatory field. This argument denotes the value you want to search in the array. The lookup array is also a mandatory field. This denotes the data array or the cell range from which you want the function to look for the lookup value. Match type is an optional field and can take only the values -1, 0, and 1. This field defines how you want the function to search the lookup value in the lookup array. When the match type argument is 0, the match function searches for and finds the first occurring value in the array exactly equal to the lookup value. When the match type value is -1, the function finds the exact or the smallest value greater than or equal to the lookup value. However, when using this match type, make sure the array is sorted in descending order. When the match type is value 1, the match function finds the exact or largest value lesser than or equal to the lookup value. However, the values in the lookup array must be arranged in ascending order. Since this is an optional field, the default value will be 1 even if you mention it in the formula or not. Let us now see how to use the match function in Excel with the match type 0. To find the exact match for the particular value, first, choose a destination cell. Enter the formula equals match and pass the arguments as the value, cell range, and the match type. Press enter. This gives you the position of the search data. That is all, everyone. The match function can be a very helpful tool that helps you find the relative position of the value. This can help find, replace, or make any changes to the data. In this video, we saw how to use the match function in Excel along with its use cases. Thank you.
Now that I've shown you how you can combine the index and match functions to perform a powerful complex lookup, we're going to see how we can do exactly the same thing in a different way. And when I say in a different way, I mean using 2 brand new functions in Excel 2021, and that is XLOOKUP and XMATCH. Now, as I said, these 2 functions are brand new to Excel 2021. And XLOOKUP is really another way of performing a lookup very similar to index and match. So it has all of the same flexibility that we love about index and match, but it's a lot easier to construct. So let's use the same examples, but this time, instead of index and match, we're going to use XLOOKUP. So let's click in our cell. I'm going to type in equals XLOOKUP. Now, the first difference you'll notice here is that we do have a lot more arguments. And it's only the first 3 that are mandatory. All of the others, the last 3, are all optional arguments. Now, we're going to go through all of them just so you can see exactly what they do. But if you just wanted to do a basic lookup, you could just use the first 3 arguments. So the first argument is lookup value. So our lookup value is going to be whatever we have in cell H5, comma. What is our lookup array? So where are we going to find Google Docs? Well, we're going to find it in the apps list. So this is our lookup array. And then we simply need to specify the return array. So what do we want to return? We want to return the category. So all we need to do is select the return array. That is basically it. I could close off my formula, hit enter, and I'm going to get my answer. Now, how much easier is that than doing the same thing using index and match? Now, let's double click to go back into this formula because I did say I wanted to run through all of these arguments. So the next argument is if not found. So we have some additional things we can specify here. So if the lookup value is not found in the table, we can choose to return a value that we specify. So that might be a piece of text. Remember, text needs to go in quote marks. So I might just want to say here, not found. Comma. I can choose what type of match I'm doing. Do I want to do an exact match? Do I want to do an exact match or next smaller item or next larger item? Well, I'm going to do an exact match. I want it to exactly match Google Docs. And then the final optional argument that we have here is the search mode. So with this particular argument, we can choose which way or how we're searching through this table. So I can choose to search from first to last or last to first. Now, if I do first to last, let's type 1 as our final argument, it's going to return the result of productivity. Now, we're going to do XLOOKUP again to return the profit and the revenue, but we're going to do this in a slightly different way again. Now, so far we've seen how we can create named ranges and use those in our formulas, but what about if I want to put this data in an Excel table? Well, what I'm going to do is click in my data and press Ctrl-T. Yes, my table has headers. Let's click on OK. Now, I don't particularly like this formatting, so let's change that. That looks a little bit better. And I'm going to give my table a name. So let's call this apps_list and hit enter. So now what I could do when I'm constructing this XLOOKUP, let's do it again. So XLOOKUP, our lookup value is what we have in cell H5. My lookup array is a table this time. Now I've called my table apps list, so I'm just going to start to type it, double click to select that table. Now it's selected the entire table, but my lookup array is just the app column. So what I can do here is press the square bracket and it's going to show me all of the different columns of that table. So I can then go through and just select the app column. Press the tab key to select it and close that bracket. So now I've isolated that column. Comma. What is my return array? Well, my return array this time, I want to return the profit. So again, I could use my table columns. Let's choose the table, square bracket, and I want to choose the profit column this time. Tab key to select and close that square bracket. Now, if I want to essentially skip over an argument, so I don't particularly want to have any if not found text, I can just press 2 commas to move on to the next argument. I want to do an exact match and I want to search first to last. Close the bracket, hit enter, and it's going to return my result. Let's double check to make sure that this is correct. So let's find Google Docs, and I can see that yes, the profit is 1166. Now for our final XLOOKUP just here, I want to focus in on that search mode, so which way we're searching through our data. So let's do our XLOOKUP one more time. Our lookup value is H5. Our lookup array, well, I'm going to use my table range again. I'm looking up the app in the app column. The return array this time is going to be the revenue. So let's select our table and the column. I'm not going to put in any if not found text. Let's press another comma to go on to the next argument. I want to do an exact match and I'm going to search first to last. Close the bracket, hit enter, and I get my result. Now with that search mode, searching first to last, that works perfectly fine for the data that I'm using. But what if I have Google Docs listed twice in this table? So what I'm going to do is on the bottom here, I'm just going to add another row for Google Docs. And we're going to assign it to a different category. So let's say utility. It's going to be Google Docs again. And let's just give it a value of 50,000 with a profit of, let's say, 5,000. Now I'm just going to expand my table out to accommodate that new data. So now effectively I have Google Docs listed twice in this apps list. Now currently, if we use the revenue as an example, it's showing me the revenue of the first Google Docs that it finds in this list because I chose to search from first to last. But if we double click to edit this formula, what I could do is I could change this to something different. So let's do search last to first, -1, and hit enter, and we get a completely different result. This time it's searching from the bottom upwards, and the first Google Docs entry it comes to is this one just here. So it's returning a result of 50,000 for the revenue. So that's how that search mode option works. But as I said, in its most basic form, if you don't want to use all of those optional arguments, you just have 3 arguments: lookup value, lookup array, and return array. Super simple. So now we know what XLOOKUP does. What does XMATCH do? Well, XMATCH is fairly similar in many ways. We have a lot more arguments than we do when we're using just the basic match. So what I could do up here is, if I want to go back to using index and match, I could do an index with an XMATCH instead. Our array is the category, so let's select it. And notice that because I have this data in a table, it's automatically going to put the table name and the column name in for me. Row number. Now, if you recall previously, we were using the match function to automate the finding of that row number. But what I could do is use the new XMATCH function instead. Again, the last 2 arguments here are optional arguments. Now, my lookup value is what we have in H5. My lookup array is where I'm going to find that, so that's in this apps list. I can then choose a match mode, so I want to do an exact match, and then I also get that search mode option when using XMATCH as well. So I can choose if I want to search from first to last, last to first, or start doing a binary search and sorting in ascending order. So let's do last to first again, -1. Close the bracket, hit enter. I can see that I've forgotten to add an additional bracket on the end, so I'm going to accept the correction. And it pulls back the category of utility because it's finding this entry first because it's searching last to first. Now you can also use XMATCH on its own when not combined with index, and it works very similar to the match function on its own. It's basically going to tell you what the row number is. So the arguments are pretty similar. Lookup value. Lookup array is where we're going to find that, which is just here. My match mode is exact, and I'm going to search. Let's do first to last this time. Close the bracket, hit enter, and it's going to tell me what row Google Docs resides in from the top. So pretty much the same results that you get with match, but it's just a little bit more flexible. You have a few more options in there. So that is your introduction to 2 brand new functions in Excel 2021.
Hello everyone, welcome to a new tutorial from Simon Says It. In this video, I will show you how to count cells with text in Excel. In a spreadsheet consisting of different data types, you might sometimes have to pinpoint the cells with the text and count them to perform any function or operation. There are 3 cases that occur when you count cells with text in Excel. Let us see them one after the other. To count all the text values in a given Excel sheet, you can use the COUNTIF function along with a wildcard character. This function with a wildcard counts all the text values in a given range. To count the cells with text in Excel, choose a destination cell and enter the formula. The asterisk symbol specifies anything other than numbers to be counted, including blank spaces and special characters. However, this method does not count logical values. You can use the same COUNTIF function and wildcards to count the number of cells with text in them. This method only counts cells that hold any text value and does not count any blank cell in the given range. To count the cells which have text values in them, enter the formula. In the destination cell, this is the same as the previous case, but adding the question mark wildcard together with the star wildcard only counts the cells which have text values. There is another case that occurs when you count cells with text in Excel, and it is used when you have to count specific words in Excel. To count the cells with the specific value, you can just enter the text to count within quotations in the formula. Suppose you want to count the occurrences of a particular word in a range of cells. You can just enter the formula to count the occurrences of the particular word in the given range of cells. Knowing how to count cells with text in Excel is essential for using some functions in Excel. Hope you learned how to convert text to numbers in Excel. Thank you.
Hello everyone and welcome back to this course on Excel for Business Analysts. We've made it all the way down to section 4, and in this section we're going to be talking about how to make better decisions using logical functions. And more specifically in this first module, we're going to concentrate on one of the most popular logical functions, and that is the IF function. Now if you're looking for the IF function on the ribbon, you'll find it under the Formulas tab in the Functions library underneath Logical. This is where you have a list of all of the functions that belong to that logical functions group. Now, if you're not entirely sure what a logical function is, don't worry too much. I'm going to explain it from the very beginning. So what I have on the screen here is a very basic spreadsheet. It is a list of tech sales for a technology company called Microworld. And you can see in column A, we have the product that they sell. We have the customer. We have the date, we have the item cost, the number of items, and the total cost. And what you'll see is that the total cost, if we look up in that formula bar, is basically D7, the item cost, multiplied by E7, the number of items. That is how we get to our total cost figure. And what we want to do here is we need to work out the shipping and the total. And in order to do that, we're going to use the if function. Now, when it comes to working out the shipping, we have some useful information just above. So you can see here, it says that there is no shipping charge for orders over $1,500, but for everything else, there is a 2% of the total cost shipping charge. Now, if we just jump in here and type in if and open a bracket, you'll see the arguments that we have. The first thing that's highlighted is the logical test. And then essentially, depending on if that logical test is true, you get one value. If the result of the logical test is false, you get another one. So taking a look at our example here, what would be our logical test? Well, we know that there is no shipping charge for orders over $1,500, but there is for anything under $1,500. So our logical test is going to be if the total cost, F7, is greater than or equal to 1,500. And you'll find that with a lot of logical functions, you're going to use those operators, the greater than, less than, equal to, so on and so forth. So that is our test. Is the total cost greater than or equal to 1,500? Let's press comma and move on to our next argument. So now we want to say, what do we want Excel to do if that is true? So if the total cost is greater than or equal to 1,500, what do we want to do? Well, I can see here that there is no shipping charge for orders over 1,500. So I'm going to say I want Excel to do nothing. Comma. What do we do if that logical test is false? So if the total cost is less than 1,500, what do we need Excel to do? Well, if it is less than, I want Excel to work out what 2% of that total cost is and use that as the shipping charge. So we're going to say F7 multiplied by 2% and close our bracket. Let's hit enter and see what we get. So I've got the first number inputted there. It's showing me $29. And what I'm actually going to do is just apply some accounting format to this column. And I can double click the autofill handle to copy that formula down. And what we should see, and it's a very nice quick way to be able to do a visual check, is that anything that's equal to or greater than 1500 should have no shipping charge. So I can see here where we have a dash that one is over 1500. And I can see as I scroll down that appears to be true. Everything else that's under 1500, we've worked out what 2% of the total cost is, and we've got that as our shipping fee. So just to recap again, we have logical test, value if true, value if false. And our final calculation in the totals column is a very straightforward sum calculation. So we're simply going to add the total cost, F7, to the shipping cost, G7. Close the bracket and hit enter. Once again, I'm going to apply some accounting formatting to this column, and I'm going to double click to copy that down. And now we have all of our figures. So very quickly, we've been able to work out everything we need for this particular data set. Hopefully that explains how if works a little bit more. We're going to move on to some more examples of if, so please join me in the next module for that. Hello everyone and welcome back to this course on Excel for Business Analysts. We're down in section 4 where we're taking a look at logical functions, and in the previous module we took our first look at how to utilize that if function. In this module we're going to do another example of if on slightly different data. So in front of me here I have some employee data, so this might be for somebody who works in HR. And what we have in column A is a list of employee names. We have the building that they work in and their department. We have the hire date, the years that they've been employed, their salary, and then they've been given a job rating. So this job rating might be something that's been generated from a yearly appraisal, and each staff member has been ranked from 1 to 5. And depending on what they've been ranked determines if they get a bonus or not. And we're going to utilize the if function in a couple of different ways to work out who is going to receive a bonus. So what we're going to say here is that anybody who has achieved a job rating of 5 is going to get a bonus of $3,000. So I'm going to click in cell H2 and we're going to fire up our if function. And if you remember from previously, we need to first state our logical test. So in this case, our logical test is if the job rating, G2, is equal to 5, comma, what happens or what do we want Excel to do if that is in fact true? Well, if the employee has a job rating of 5, they're going to get a bonus of $3,000. If they have anything that isn't 5, they're going to get absolutely nothing, which is a little bit unfair, but there we go. Close off the bracket, hit enter, and now if I copy this down by double-clicking the autofill handle, we'll see that we have 3,000 listed wherever there is a job rating of 5. So it's very easy for us to then see which staff members have received that bonus. And once again, I'm going to highlight this column and I'm just going to apply some currency formatting. So now let's take this on a stage further. I'm going to double click to jump back into my if function. And what we're going to do here is instead of having just a 0 or a dash, we're going to replace that with some text. So I'm going to remove the 0, and what I'm going to say is that if the job rating is equal to 5, I just want it to say in the cell bonus. And when you're dealing with text within a formula, you must always put it in quote marks. Comma, what do we want it to say if the logical test is false? Well, I want it to say no bonus. And hit enter. And now if I double click to copy that down, you can see we get those results. So essentially what I could do if I wanted to quickly analyze this data and just get a list of everybody who's going to receive a bonus, I could do that very quickly by combining this with some filters. So I'm going to jump up to my data ribbon, make sure that I'm clicked somewhere in this heading row, and I'm going to click on the Filter button. This applies these little filters to each of the heading rows, and what I can then do is filter just for bonus. Click on OK, and it's going to show me all of the people who are going to receive a bonus. Now, so far in the two examples that I've shown you, I've been hard coding values into this particular formula. So I hard coded in $3,000 into that if formula, which means if the bonus amount changes, I'm going to have to go into my formula and I'm going to have to change it. What I could do is, if I wanted to, have my bonus listed somewhere else. So maybe I could have bonus just here. And then underneath it can say 3,000. And I'm going to apply some formatting to that. And instead of actually hard coding 3,000 into the formula, I can then utilize cell references. So let's do our formula again. Equals if, open bracket, our logical test is if the job rating is equal to 5, comma, if that's true, then they're going to get a bonus of 3,000, but we're going to utilize the cell reference instead, J4. Now remember, because we're going to copy this formula down, we want to make sure that we fix this cell J4 so Excel doesn't try to move down one cell. So we're going to do that by pressing our F4 key to add dollar symbols in front of the row and the column. Comma. If they don't have a job rating of 5, then they're going to get 0. And then, of course, we can copy that down and we get our result of 3,000. But the difference being, if I want to very quickly update this bonus to 3,500, I just need to change it in one place and all of my figures are going to update. The final example I'm going to show you in this module is if we want to maybe set the bonus as a percentage of their salary. Again, if we jump into cell H2 and say equals if, open bracket, our logical test is exactly the same. If the job rating is equal to 5, comma, if that's true, then they're going to get a bonus of 15% of their salary. So I want to say salary, which is F2, multiplied by 15%. And as I was saying previously, I've hard-coded the 15% into the formula, but you could very simply have the 15% listed over at the side in a different cell and utilize the cell reference. Comma, if they don't have a job rating of 5, they are going to get nothing once more. And we can go in and copy this down, and there we can see our figures. So a few different ways there that you can utilize the if function in various different formats, utilize text, utilize cell references, etc. in order to extract the results that you need. In the next module, we're going to move on to something called nested if statements. So please join me for that. Hello everyone and welcome back to this course on Excel for business analysts. We're down in section 4 where we've been looking at logical functions and in particular the if function, one of the most popular functions in Excel and something that you really need to wrap your head around if you work in business analysis. Now in the previous couple of modules we've taken a look at some basic examples of if and how you can utilize it in different ways. In this module, I want to move on from that idea and just show you how you can construct what we call a nested if statement. Now, when we say a nested if statement, what we essentially mean is an if statement or multiple if statements within an if statement. Now, that might sound a little bit confusing at this stage, but hopefully this very simple example using the data we used in the previous module will make it all a lot clearer. So once again, just a reminder of our data. We have employee names and we have the building department that they work in. We have their hire date. We have the years that they've been employed, their salary and their job rating. And in the previous example, we were giving out bonuses for all of the employees that had a job rating of 5. Now it seems a little bit stingy to only give employees that have a job rating of 5 an annual bonus. So what we're going to do is we're going to dish out some more money using nested ifs. So I'm going to jump into cell H2 and we're going to start off with our equals if function again. Now our logical test is going to be the same. So if the job rating is equal to 5, comma, and I'm going to start out by hard coding in what the bonus is going to be if that logical test is true. And just to keep things consistent, we're going to stick with 3,000, comma. Now this is where the nested part comes in, because what I want to do now is say if the job rating is 4, the employee is going to receive $1,500. So instead of providing a false argument at this stage, I'm going to add in another if and open the bracket. And I'm going to do exactly the same thing. If the job rating is equal to 4 this time, then that employee is going to get $1,500, comma. Let's add in another one. If, open bracket, the job rating is equal to 3, then the employee is going to get $900 bonus. And we can carry on going. So let's do one more, comma. If the job rating is equal to 2, then they're going to get $500 bonus, comma. And what I'm going to say is that if somebody's got a job rating of 1, then they're not going to get anything. So we're going to say, comma, 0 on the end. Now with these longer nested if statements, what you need to remember is that for each bracket that you've opened, you need to close off as many at the end. So I can see that I have 1, 2, 3, 4 open brackets, so I need to close off 4. 1, 2, 3, 4, and hit enter. Now the first one is showing me nothing, and that is a job rating of 1, so that appears to be correct. I'm going to copy this formula down, and what I should see is that I have figures filled in for anyone with a job rating of 2, 3, 4, or 5, and whenever the job rating is 1, there is no bonus. So that appears to be working very nicely using those nested if statements. And as you can imagine, if you have a lot of data, these can get pretty long. And in the next module, I'm going to show you a way that you can kind of shorten this up a little bit. But it's really important that you understand this concept of nesting functions inside other functions. Now, of course, as we saw previously, we could also utilize cell references to construct our nested if statements. So what I've done here is I've just added a little table over at the side that shows me the ratings 1 to 5 and the bonus for each of those ratings. So instead of hard coding these numbers into the formula, which makes them a little bit more difficult to change, I can just reference the cell from this little table instead. So let's take a look at how that would look. We're just going to say equals if, open bracket, our logical test is the job rating. If that's equal to 5, then they're going to get a bonus of 3,000, which is cell K8. And remember, we need to lock that in place by pressing the F4 key to make it absolute, because we're going to copy this down. Comma, if, open bracket, the job rating is equal to 4, then they're going to get a bonus of 1,500 and lock that in place with the F4 key. And I could carry on going as I did before, but in this case, I'm just going to leave it there. I'm going to do my final argument. For anybody else who hasn't got a job rating of 4 or 5, they're going to get nothing in this case. And I need to close off 2 brackets because I've opened 2. Enter, and then double click to autofill that down. And of course, as we've seen before, if these numbers now change, everything is going to automatically update. So let's change the bonus for a job rating of 4 to 1,700, hit enter, and all my numbers have updated very simply. Hopefully those examples have demystified nested if statements a little bit more for you. In the next module, I'm going to talk to you about the newer IFS function, which really makes nested if statements a lot more concise and a lot shorter. So please join me in the next module for that. Hello everyone and welcome back to this course on Excel for Business Analysts. We're down in section 4 where we've been taking a look at how to make better decisions using the IF function. And in the previous modules we've seen a couple of basic examples of how to utilize if, and we've also looked at how to utilize nested ifs, that is, if statements within if statements. And if you remember, we had a very small example. But when working with nested ifs, the formula can become quite long and quite cumbersome. Imagine if you had a lot more data and a lot more if statements that you need to add in, that formula would become extremely long. So what we're going to do in this module is we're going to take a look at Excel's new alternative to working with nested ifs. And that is the IFS or the IFS function. I like to call it IFS to differentiate from regular ifs. Now, one thing to note here is that the new IFS function is not available in all versions of Excel. So if you have Excel 2016, 2019 for Office 365, then you should find that you have access to the IFS function. If you're not sure which version you're using, a very quick way of checking if you have access to the function is just to click in a cell, type it in, and if you can see it listed underneath, then you are good to go. If you don't have this function, then you will need to use nested ifs, as I demonstrated in the last module, until you upgrade and have access to this new function. So let's take a look at how the IFS function works. So I have an example on my screen here, and this is just some test results for an English exam. And I have these student names, I have their score, and what I want to determine here is whether they passed, failed, or if they need to retake. And just above, I have the threshold, the pass mark they need to achieve. So essentially, if they score above 75%, they have passed. If they score below 75%, they have failed. And what we're going to say is if they have achieved exactly 75%, they're going to need to retake the exam. So I'm going to use the IFS function in order to populate these empty cells in column C with the result. So let's jump into our first cell, C6, and I'm going to type in equals ifs and open my bracket. Now the difference with IFS as opposed to nested ifs, if you look at the arguments underneath, we're only required to provide a logical test and a value if true. We don't need to provide a value if false, and that essentially makes this formula a lot more concise to read and a lot more concise to construct. So let's type in our first logical test. We're going to say if the score, which is in cell B6, is greater than 75, and we're going to lock that cell because we're going to copy this down by pressing the F4 key, comma. If that is true, then the student is going to pass, comma. You'll see now it moves straight on to logical test 2. We haven't had to provide what we want Excel to do if it's false. So let's do the next logical test. If the score is less than 75, and we're going to lock that by pressing F4, comma, we're going to say fail. Now for the time being, I'm just going to do those two. I'm going to close off my bracket, I'm going to hit enter, and I'm going to double click my autofill handle to copy that down. So we can see here we have anything under 75 is listed as a fail, and anything over is listed as a pass. But take a look at this score here, which is dead on 75. Currently, that's telling us NA. It's giving us an error. And that is because we haven't told Excel what we want it to do if the score is 75. All we've said is if it's above 75, it's a pass. If it's below, it's a fail. Now this is fairly easy to solve. What I could do is just jump back into my formula, click on the end, and provide another logical test. So I could say if the score is equal to 75 and lock that in place, then I want it to say retake and hit enter. And now if I send that down, I get exactly what I'm looking for. Now there is another way that we could deal with this. Now it's perfectly fine to do it that way. And because I have a fairly small data set, it's very easy just to add in that third logical test. However, there is a slightly different way that we could do this. I'm just going to remove that last logical test that we added in. And instead of actually providing that logical test, I'm just going to type the word true, comma, and I'm going to say retake. Hit enter, and if I copy that down, I should find that my results don't change. So why is this working? What is this true argument and what exactly is it doing? Well, the way that this formula works is that Excel is looking for the first true condition in order to produce a result. So if we take this first score, for example, 67, essentially Excel starts to run through this formula looking for the first true result, and then it returns whatever text that corresponds to that. So if I just highlight this first logical test, and what we can do here is just calculate this formula so we can see the results. You can either press the F9 key, or on the formulas ribbon, you can choose the calculate now option. You can see that this first logical test calculates to false for this first score. So what Excel does, it says, okay, that's a false. It moves on to the next calculation. So if we highlight the next logical test and do F9 or calculate now, it finds true and so returns the result of fail. And it basically goes through all of these and does exactly the same process. It's looking for the first true. When it finds it, it will produce the result that relates to it. Now with this one here, where it's dead on 75, let's double click. Let's highlight and do F9 or calculate now. We have a false. It moves across to the next one. We still have a false. And so because we've hard-coded true as our third logical test, it's going to produce true. So this is a nice kind of catch-all option to add into your formula. Now just to finish off this module on IFS, one little thing you might want to do to make these stand out a little bit more is combine this with conditional formatting in order to maybe highlight the results which are showing as fail, or maybe highlight the results that are showing as pass. So let me very quickly show you how you can do that. I'm going to start out by highlighting all of my results. I'm going to go up to the home ribbon and across to conditional formatting, and I'm going to create a new rule. I'm going to select a rule type. I'm going to say format only cells that contain, and then because my cells contain text, I'm going to make sure I say specific text, containing, and let's say the word pass. I want all of those results formatted in a green color. Click on OK, click on OK again, and now I can very easily see all of the people that have passed this test. You could, of course, go through and create another rule to highlight the results that are fail, or maybe the ones that are retake as well, but that's just a nice way of combining conditional formatting with IFS in order to analyze your data a little bit more effectively. I recently conducted a poll on LinkedIn where I asked all of my followers and connections to let me know which functions in Excel they find the most useful. And by far the clear winner was COUNTIFs and SUMIFs. And both of these functions, as well as their sister functions, average if, min if, and max if, are effectively if statements which have conditions or have criteria. And there's a really important distinction to make here. In this lesson, we're going to talk about COUNTIF, SUMIF, and average if. In the next lesson, we're going to talk about COUNTIFs, plural, SUMIFs, average ifs. And those latter three are newer additions to Excel. The original functions that we've had for quite a while now are the singular COUNTIF, SUMIF, AVERAGEIF. So let's start out in this lesson by taking a look at how those work, and then we'll add a bit of complexity to it in the next lesson. What we have here is a small table. We have some sales team members. We have the company that they work for. We've just got 2 companies in here. We have their job titles, so they're either a sales rep or a sales manager. And then we have the total amount in dollars that they've sold. Now, what I want to find out is some information, but based on criteria. So if we take a look at this first table and just concentrate on this first one, my criteria is going to be microworld, because what I want to work out here are the total sales for microworld. So we're adding in a condition where we have to tell the formula, perform a sum calculation of the total sales, but only when the company is equal to microworld. So we only want to add up those total sales. So in this scenario, where we have one piece of criteria, which is microworld, we use the singular form SUMIF. And this is a fairly straightforward calculation to do. So let's type in equals SUMIF. What arguments do we have here? Well, our first argument is range, our second argument is criteria, and then we have a third optional argument. How do I know this is an optional argument? Well, it's enclosed in square brackets. So every time you see an argument that has square brackets around the outside, it means it's not a mandatory piece of criteria. You don't have to include it in order to get this formula to work. Now, we are going to include some range in this calculation, so we're going to use all of the arguments. Now, our first argument here is range, and then we have criteria. Now, I like to work backwards when I'm thinking about this. What is my criteria in this formula? Well, my criteria is microworld. So my range is going to be wherever I'm going to find the word microworld. So I'm going to find that in the company range. So my first argument here is the range, and then I can specify the criteria that I'm looking for. So the criteria I have listed in cell F6. Now again, I could have hard-coded in the word microworld, in quote marks of course. But as I said, wherever possible, try and use cell references. Now the final argument here is that optional argument of sum range. Now in this case, I do need this, because otherwise Excel isn't going to know what I want to add up. I haven't told it to add up the total sales yet. So my sum range is going to be total sales. Close the bracket, hit enter, and there is my result. So let's review. We're saying sum if the company range equals microworld. If it does, sum the total sales. So that is SUMIF, where we use a single piece of criteria, in this case microworld. Let's take a look at how this would work if we're counting as opposed to summing. So in this second example, again, we have one piece of criteria. I want to work out the total number of employees at COMPUTEC. So effectively, I want it to look through this table, and wherever it finds COMPUTEC, I want it to count the number of entries, and that's effectively going to give me the number of employees that work there. So for this, we have one piece of criteria, so we're using COUNTIF singular. This time we have 2 arguments, range and criteria. Again, I like to work backwards. My criteria is going to be COMPUTEC. Which range am I going to find that in? I'm going to find it in the company range. Comma, my criteria is COMPUTEC, effectively cell F14. Close the bracket, hit enter. It's telling me there are 6 employees at COMPUTEC, and because my dataset is reasonably small, I can just do a quick visual check just there, and yes, I do have 6 employees. It's also worth noting that down in the status bar, if you take a look over on the right hand side, it's telling me the count is 6. Now, if you can't see that information, a little quick tip here: if you right click in the status bar, make sure you have average count, numerical count, min, max and sum turned on, so that when you start selecting things in your worksheet, you can see all of those values in the status bar at the bottom. So let's do the final calculation down here. This is just doing an average. So this time I want to find the average sales for COMPUTEC. Again, one piece of criteria. So this time we're going to use average if in its singular form. We have 3 arguments just here. My criteria is COMPUTEC, so the range is going to be company. The criteria is COMPUTEC, and the average range, well, I'm looking for the average of the sales. So I want to use the sales range. Close the bracket, hit enter, and now I get my average. So that is how we can use those 3 super useful formulas to return results based on one piece of criteria. COUNTBLANK is one of those formulas that pretty much does exactly what it says on the tin. It counts all blank cells in a selected range. And sometimes this can be really useful in many different scenarios. So let's take a look at how COUNTBLANK works. Now in this first example, we have a table on the left-hand side that just has some order IDs, some customer names, and then we have email addresses for some of our customers. Now it appears that some of the customers haven't left their email address when they've placed an order. So I've been tasked by my manager to go through all of our customers and tell him how many haven't left an email address. And this is really going to determine if we're going to spend any money on developing our order system and making email addresses mandatory prior to placing an order. So I can use the COUNTBLANK function for this. And it works exactly as you would expect. We're going to type in equals, and it's this one just here, COUNTBLANK. And we have one argument for this, and that is the range of cells. So all I need to do here is select this range, C4 to C23, and it's going to tell me that out of 20 customers, 7 of them have not left their email address. Now currently this data that I'm reviewing isn't in a table. So as I add more customers to the bottom of this list, my COUNTBLANK formula isn't going to update. So again, this is another reason why using tables is so important. Let's press Ctrl T, click on OK, and I'm going to leave the table style as it is. Let's give our table a name. We're going to call this orders. And now I'm going to update my COUNTBLANK formula. So let's replace the cell reference with the table name this time and hit enter. So now if we add a new customer onto the bottom, so let's say the order number is 1020, and I'm just going to use my name, why not? Notice that my formula has updated, so now we have 8 people in the list who don't have an email address. Now if I was to add my email address in here, and I will say that this isn't my actual email address, but let's add one in and hit enter, that COUNTBLANK formula goes back down to 7 because it's no longer a blank cell. So make sure that you put your data in a table and then your COUNTBLANK formula will constantly update. Now another quick tip here, notice as I've entered in my email address, it's automatically turned it into a hyperlink. Now the other email addresses in here are not hyperlinks, so if you just want to remove that hyperlink and just have it as plain text, just right click on the cell and choose Remove Hyperlink. Let's take a look at another example of using COUNTBLANK. Now what I have in the table on the right hand side are a list of employees, and I have days of the week across the top, and then I have a Y which tells me on which days these employees are scheduled to work. And the first thing I want to do here is I want to just do a count of how many days each employee is working. So this is just a straightforward count A. I'm going to select this row, close the bracket and hit enter, and then I can copy that formula down, and that just lets me know how many days each of my employees is scheduled to work. Now, what about if my manager comes to me and he's looking at rearranging the scheduling around a little bit because we need more cover on certain busier days? What would be really useful to know is how many employees are off on Mondays, how many are off on Tuesdays, Wednesdays, so on and so forth. And this is where the COUNTBLANK function can come in really handy in a practical example. So let's go for COUNTBLANK. Our range, we just want to select Monday. close the bracket, hit enter, and then I can drag this formula across and I can see how many employees we have off each day. So on Saturday, we have the most amount of employees off, but Friday and Saturday are our busiest evenings. So this is really going to help my manager when it comes to analysing how he wants to reorder the scheduling of staff. So COUNTBLANK can be used in many different situations and is a really useful formula to have in your Excel toolkit. The new let function is part of the logical group of functions in Excel. And what let basically allows you to do is assign names to calculation results inside a formula. So if you find yourself writing the same expression multiple times in a formula, let basically allows you to name the expression, and then Excel will calculate the result using the name. So not only is this a great time-saving function, but it also makes your formulas easier to read and understand, as you don't have to remember what a specific cell reference or range refers to, because it's right there in the formula. So let's start out taking a look at the let syntax, and also let's run through a couple of basic examples. So in cell A4, I'm just going to type in equals let. And you can see here the different arguments that we have for the let function. We have name1, name value1, calculation, or name2. So name1 and name1 value are where we define the name and the value. And then the last thing we do is the calculation. And we could have numerous pairs of names and values in our formula. In fact, the let function supports up to 126 pairs. Now, you might be listening to this thinking, okay, I kind of understand what you're saying there, but it doesn't really make sense. And that is completely understandable, because this is one of those formulas that only makes sense when you see it in action. So let's take a look at a very basic example. So the first thing I'm going to do here is I'm going to assign a name to a variable. And for argument's sake, and because I'm not very good at thinking up variable names, I'm simply going to call this first one var, comma. Now I can assign a value to the word var. So if I assign the value 20 to this word, effectively the word var now represents 20. Now I could carry on going, adding other names and values, or I could perform a calculation using the variable that I've just set up. So if I now do a calculation, it might look something like this. I could say var plus 5. Now what do you think the result of that calculation is going to be? We've stated that var equals 20. That is our variable. Those are our parameters. And now my calculation is var plus 5. So as we would expect, the result is 25 because we're just adding 20 to 5. So that's an example of a simple let just using one variable. Let's add another variable. So if var is equal to 20, let's add another variable. I'm going to say comma, and remember, our next argument is calculation or name2. So this time we're going to add another name and another name value. So let's say that x is attributed to the value 10. So now what I could do is I could modify my calculation at the end here, and I could do var divided by x. What result do you think I'm going to get? Well, I'm going to get a result of 2. Because we're effectively doing 20 divided by 10. So hopefully you're getting the idea here. We set up a name, we attribute a number to that name, and we can set up 126 different pairs of names and variables in here if we want to. The last thing we do is we perform calculations using the variables that we've created. So everything is defined within one formula. Let's define a third variable. So let's double click to edit the formula, We're going to click after the second variable, and this variable we're going to name y, and this is going to be 5. I'm now going to change my calculation to do var divided by x, and I want it to do this part of the formula first. So we're going to put it in brackets, and then I want it to plus y. Let's hit enter. We get a result of 7. So we're doing 20 divided by 10, which gives us 2, and then we're adding 5. Let's take a look at another example of using the let formula. So if we scroll down, again, we just have a basic table that shows some employee names, and we have their salary. And each of these employees is going to get a bonus of 20%. So this is a fairly simple calculation. We can just simply do a sum, and we multiply the salary by the bonus, and we need to make that absolute, and then we add the salary onto the bonus. Let's close the bracket and hit enter, and we get our result of 54,000. So how could we use let to perform this calculation? Well, let's click in the cell underneath, and I'm going to do this up in the formula bar and just show you a slightly different way to put together your calculations. Now, this formula bar isn't a set size. If you notice, if I hover my mouse over the bottom part of the formula bar, we get a double-headed arrow. So if I click and drag this down, I get a much larger formula bar. And sometimes when you're putting together more complex formulas, it's really helpful to be able to lay them out in the formula bar and have different parts of the calculation on different lines. It just adds to the readability of your formulas. So let's go into let. Open the bracket. Now I'm going to declare my variables on the next line. So we need to press Alt-Enter to move our cursor down. So let's declare our first variable. Well, what do I select first when I'm doing the sum calculation? I select the salary cell. So I'm just going to call this first variable salary, and salary is going to reference cell B17. What's the next part of my sum calculation? Well, we multiply the salary by the bonus. So the next variable that I'm going to declare, and let's put it on a new line, or enter, is going to be the bonus. And the bonus is cell F15, and we need to press F4 to lock that. So now we've declared our two variables, we can perform our calculation. So Alt-Enter to move on to the next line. Our calculation is going to be sum, open bracket. We're doing the salary, and notice as I start to type it in, it comes up in Excel's IntelliSense, so I can simply press the Tab key to select it. We want to multiply by the bonus. Again, it's come up, so Tab key to select. And then we want to plus the salary again. Close the bracket and close off our let. So that is our calculation on the last line. Now take a look at the way that we've structured that. It makes it a lot easier to read. We have our function name on the first line. We then have our variables declared on lines 2 and 3. And then at the bottom, we have our calculation. Let's hit enter and see if this works. And in fact, yes, it does. So now all I need to do is double click and I can copy that formula down. So hopefully now you're getting the idea as to how this let function works. Let's take a look at one last more complex formula. So let's move to our final worksheet. Now this data may look familiar to you. We did use this when we were looking at the filter function. I have some block names, we have the subject, and we have the pass mark. So this might be information for students who took a test. And basically what I want to do is use the filter function to return the block, the subject, and the pass mark based on the criteria that we have in the middle here. So currently, if I was using filter, I'd only want to see results where the block equals West and the subject equals English. So let's first just do this using the filter function, and then we can see how we can convert that into a let. So let's type in equals filter. Our array, well, our array are the results that we want returned, which is pretty much everything in this table. comma. Now we need to specify what we want to include. So let's open a bracket. I want to include all results where the block equals west. So we need to select the block range, and that needs to equal what we have in cell E3, F4 to lock. Let's close the bracket. We also want to return results where the subject is English. And because this is an AND calculation, we want to return both results. We're going to separate with an asterisk. Open the second bracket, select the subject range, and that needs to equal what we have in cell E7, F4 to lock. Let's close off our bracket, close off our filter, hit enter, and would you take a look at that? There are our results. So we're going to do pretty much the same thing, but we're going to set this up as a let instead. And this is where lets can be particularly useful, because if you take a look at this filter formula, notice lots of cell references in here. So we can effectively replace these cell references with more meaningful names using let. And this is particularly useful if you have repeating cell references in your formula, because it means that you can declare the name for a particular cell reference and then just replace every time that cell reference occurs with the name. And not only does it make the formula a lot easier to read, it's a lot more efficient for Excel to calculate. So let's jump down to cell G9, and we're going to construct this as a let. Now I might need a bit more room here, so let's drag our formula bar down. So we're going to do this in the same format. We're going to start with our equals let. We're going to open a bracket and Alt Enter to move on to the first line. So now we want to declare our variables. Now the first thing we selected was our array, which is basically everything that we have in this table. So I'm going to call this array, let's just call it data. And then we can select the cell references, comma, Alt Enter to move to the next line. What do we then need to do? Well, we need to specify what we want to include in our filter. And the first thing is we want to include the block. So we're going to name the block range. So let's give it a name. We'll call it block, comma, and that means we're referring to this range just here, comma, Alt Enter. Now you don't necessarily have to name absolutely everything that you select in your calculations as a variable. For example, I might not want to name this cell just here where we have West. Now I am going to do this just so you can really see what this formula looks like when we name everything. And I think what I'm going to do is I'm actually going to rename the block range. I'm going to call this block RNG just to make that very specific. And then the next variable we're going to call block, and that's going to refer to this cell just here. And we're going to press F4 to lock that. Comma, let's move on to the next line, Alt Enter. The next thing we need to declare is the subject just here. So let's say subject RNG is this range just here, comma, Alt Enter. And again, if you need to, you can just drag this down to give yourself a little bit more room. And then our final variable to declare is just going to be the subject. And that is going to be this cell just here. And I'm going to press F4 to lock that. So those are all of our declared variables. We can now perform the calculation on the last line. So comma, Alt, Enter. So now it's time to put together our calculation. So we want to do our filter, our array. Well, we've declared that as the data range, comma. What do we now want to include? Well, the first thing to include, we want to select the block range, and that needs to equal whatever we have in the cell that we've called block. Asterisk, our second piece of criteria, is the subject range, and that needs to equal the subject. Close our bracket, close off our filter. So let's just take a moment to review what we have in this calculation. We have the let function name on the first line. We then declare all of our variables and what they refer to, and then we do our calculation on the last line. So let's hit enter and see what we get. Now it's telling me it's found a typo in my formula, and I think I've missed off a trailing bracket on the end here. So I'll say yes to accept the correction, and take a look at that. We're getting exactly the same results. So our let is working really well. Now let's just check if we change this to east. Let's see what happens. It still works. So hopefully that gives you an idea as to how you can use let and where it might be useful. I will say let is particularly useful if you have a large data set, if you have a complicated calculation, and particularly if you're recalling the same information over and over again in a formula. It makes it a lot more efficient for Excel to calculate, and it makes the formulas a lot easier to read and understand. In this lesson, we're going to blast through some of the most useful date and time functions in Excel. And we're pretty much going to cover most of the date and time functions that you're going to come across. So on this worksheet, we have a column A, that contains a date. And this date is currently in short date format. And we then have an invoice total. And what I want to do is I want to extract certain parts of this date into separate columns. And we're going to do this using date functions. Now, the majority of these that I'm going to show you rely on the fact that we have the full date in column A, because we're going to use this column as our reference point to extract the various different parts of this date. So effectively, we're breaking up this date into its different parts. And I'm going to show you a function in a moment that kind of does the opposite. So if you have things like the day number, the month number, and the year, how you can combine them all together into a short date format. But let's not get too far ahead of ourselves. Let's run through all of these different functions. So in column C, we want to extract the day number from the date in column A. So we have a function called day. Now notice there is only one argument for this, and that is serial number. And this is slightly misleading because what Excel means by a serial number is just the cell that contains the date. So in this case, A4. Close the bracket, hit enter. It's extracting the day part of this date. So in this case, 10. I can then double click, which is going to copy that formula down and extract the days for the rest of the date. Super easy. Now, what if I want to extract the day name from this date? And what I mean by the day name is Monday, Tuesday, Wednesday, Thursday, so on and so forth. Now, this works in a slightly different way, because if the answer that you want to extract from a date is a text-based answer, such as the day name or maybe the month name, you need to use the text formula. This function has two arguments, value and then format text. Now the value, again, is just the cell that we want to extract from. And then we need to provide the format for this day. So this is where those MMMs and DDDs come in again. So if we're extracting the day, we want to use the D, but how many Ds we use will determine if I get MON, M-O-N, or Monday. And this needs to go in quote marks because it is essentially text. Now, if I type in 3 Ds, first of all, and close my quotes and hit enter, I'm going to get the short version of the day name. Let's double click to edit. If I was to add another D in here and hit enter, I get the long day name. And then I can double click to copy that down. So just remember that when you're trying to extract things from dates, if it's text, you need to use the text function. Let's move across to the next column because this time we want to extract the month number. And for this, we use the month function. Again, one argument, which is the serial number, A4, close the bracket, hit enter, and we get the month number part of this date. Now, once again, the next thing that we're extracting is the month name. So this is going to be January, February, March, and this is text. So we need to use the text function again. Let's select our value, which is A4, and then we can choose our format, which needs to go in quote marks. So this time we're dealing with the month, so we want M's in here. If I do 3 M's, I'm going to get the short version of the month, so Jan, Feb, Mar. If I put 4 M's, I'm going to get the long version of the month. Let's hit enter, and then of course I can double click to copy that down. Really straightforward. The next one is super easy. We're extracting the year, and we have a year function. You guessed it, serial number, close the bracket, hit enter, and it's going to extract the year part of that date. And then finally, I can extract the weekday number. And we can do that using the weekday function. Now, the first argument here is the serial number, so we need the date again. And now we can specify how we number our weekdays. Now, I tend to number mine as in Monday is 1 all the way through to Sunday being 7. But some people in different parts of the world number their weekdays differently. Some people might start their week on a Sunday, and so that is number 1 to them. Some people might start on a Thursday, so on and so forth. And this is the argument where you can specify exactly that. So if I choose to put a 2 in here as this argument, it's going to number Monday as 1 through to Sunday 7. And that is exactly what I want. Close the bracket, hit enter, and now I get the weekday number. Double click. So if I just take a quick look at this, this first one is 4, and yes, Thursday, according to me, is day number 4. And if I wanted to get super fancy, and this will even give us a chance to practice a quick if statement, I could type in an if statement here which tells me if this date effectively in column A is a weekend or a weekday. So what I could say here is equals if my logical test. Well, what I can say is if the weekday is greater than 5, if that is true, then yes, it's the weekend. If it's not, then no, it isn't. Because Saturday and Sunday are effectively numbered 6 and 7. So if I hit enter and then copy this down, I should find that most of these are no, except when we get to anything that is a 6 or a 7, which will be yes, because these represent Saturday and Sunday. So some really useful functions in there. Now, I mentioned earlier that we can in fact do the reverse of that and combine values together to create a date. So if we take a look at this table at the top here, you can see I have the year in one column, the month in another column, and the day in another column. So what I can do here is use the date function. And all I need to do is specify the cell. So the year is cell K4, the month is L4, and the day is M4. Close the bracket, hit enter, and I get that date, which I can double click and copy down. I could do exactly the same for time. So equals time. We need to specify the hour, the minute, and the seconds. Close bracket, hit enter, and there I get my times. Super useful functions. Now let's jump across to the time functions worksheet, because I just want to finish off by showing you how we can do pretty much exactly the same, but this time using time as our serial number. So I have some times in this first column, and we can break those down using more functions in Excel. So the first one is the hour function. Again, it just requires a serial number, and it's going to pull out of that the hour. Double click to copy down. We have a minute function. Again, serial number is required, and we can double click to copy that down. And then finally, we can add the seconds by using the second function. Serial number, close the bracket, hit enter, and then we can double click to copy that down. Now, because of the way that I have these times, these last two are just showing zeros, and that is actually correct. It's really only this first column that has different values in it.
Hello everyone, welcome to a new tutorial from Simon Says It. In this video, let us see how to randomize a list in Excel. In some lists or tables, there might be the need to shuffle the entries randomly. We randomize the entries of a list or table while picking any random criteria in an unbiased way. Now let us see 2 ways to randomize a list in Excel with an example. One way to randomize a list is to use a combination of formulas in Excel. You can use the sort by formula with a combination of rand array and COUNTA functions with a few criteria to randomize the list. First, select any destination cell to create the random list. Enter the formula in the destination cell and press Enter. This creates a random list of entries from the selected range of cells onto the destination cell. The second method just employs the rand function to create random values and randomly sort the data. However, it employs a couple of steps to arrive at the randomly sorted data. First, select a destination cell. Enter the formula and press Enter. When you press Enter, a random value populates in the cell. Use the drag handle to apply the formula to the remaining cells. As of now, it makes no sense, and the values are not random yet. Now, with the selected cells, navigate to Data. Under the Sort and Filter section, click on Sort. You can sort the random values, either ascending or descending. Excel throws a warning suggesting you select the data adjacent to the random values. Select the Expand the selection and click Sort. Once you click on Sort, the random values will be sorted out along with the values. You can delete the random values and just keep the list that has been randomized. That is all, everyone. In this video, we saw how to randomize a list in Excel in 2 easy ways. Thank you.
If you're not a subscriber, click down below to subscribe so you get notified about similar videos we upload. To see the full course that this video came from, click over there. And click over there to see more videos from Simon Says It.